Hello, I welcome you all. The problem reads, if the engine weighs 800 pounds, determine the internal normal force, shear force, and moment at points F and H in the floor crane. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Right. So to start with, we are going to dismantle this particular frame and then try and draw free body diagram for member DB. So let's do so. So we'll have a member like this, okay, and what do we have? We have let me just move it a little bit, sorry. Okay, move it somewhere there. Right, so let's say at B we have BY and BX, and then we have another joint there, and that is CA is a two force member, so we only expect one force, and it's clear in the figure that this member is going to be in compression. So we have a force like this member is CA, okay. The slope here is given for this is 30 degrees, and the slope for CA is 60. So CA is going to have two components. It will have one component like so, and then it will have another component like so. Okay, so since you've seen the angle with the horizontal axis is 60 degrees, therefore this angle here is 62, right? It is 60 also. 60, so we'll have CA, this one is cos 60, and then this one is CA sine 60, right? And then we have a force at this point, which is the weight of the engine, which is 800 pounds, right? Let's add the dimensions. We have from there to there, this one is 2.5 feet, and then from there to here, okay, this one is by 2 or 0.75, which is 1.5 feet, right? And then we have these other components in this direction. This component here, this one is going to be equal to 1.5, this is 1.5 sine 30, and then this one here is 1.5 cos 30, and then we have finally this one, which is 4 cos 30, right? So we have this figure. Let's quickly determine BY and CA. So let's take moments about B. So we'll have summation of moments about point B equal to 0. What do we have? We have 800 by 4 cos 30. Then we have plus CA cos 60 by 1.5 sine 30, okay. And then we have minus CA sine 60 by 1.5 cos 30. Alright, think this is about it. So our CA is going to be equal to, let's calculate it quickly. We have 800. Okay, we start with this here, 1.5 cos 60 sine 30 minus 1.5 sine 60 cos 30. Okay, and then we have 800 by 4 cos 30 divided by answer. So we have 36 95.04 pounds. Alright, so we have this. Let's find the components of By. Summation of forces in the y direction equal to 0. Okay. We have minus 800 plus CA sine 60, then plus By equal to 0. Therefore, our By is going to be equal to, let's calculate, minus 800 plus CA. CA is 36, 95, 36, 95.04 sine 60. Alright, so we get, what do we get? Sorry, minus 800 plus 36, 95.04 sine 60. Alright, so By is going to be equal to minus 2,400 pounds. Alright, so this one changes direction, right? So let's find Bx, summation of forces in the x direction equal to 0. What do we have? We have Bx minus Ca cos 60. Alright. Bx therefore is going to be equal to, that's half, cos 60 is half, right? So 3695.04 cos 60 gives us half, which is just 1847.52 pounds. So we found the support reaction, the forces at the joints as well as in the two force member. So what we need to do now is to draw. We need to draw another section. We need to cut this particular member at F here, and then once we've done so, replace all the forces that we need. And when we've cut this member here, I'm going to use the right hand side section. Alright, here we go. So let's take moments about F. So we say summation of moments about point F equal to 0. What do we have? We have minus 2,400 times 0.75 cos 30. And we have plus 1847.52 by 0.75 sine 30. And then we have minus MF is equal to 0. Therefore, MF is going to be equal to, so minus 2,400 times 0.75 cos 30 and plus 1847.52 times 0.75 sine 30. Right, so we have minus 866.03 pounds feet. So let me just check it. 2,400 by 0.75 cos 30 plus 1847.52 by 0.75 sine 30. Alright, so this is what we have. We have this one. So now let's find the components for this. So we expect a component in this direction for V F, and another component like so for VF. Sorry, I'll need to write this nicely. So we know the angle is 30. Okay, if this angle is 30, therefore we expect this angle also here to be 30. Alright, so if this is 30, therefore it means this one is going to be 30. Okay, so this angle here is 30. Okay, so this angle here, let me just write it with blue. This angle here is 30 degrees. So if this is 30, therefore this becomes VF cos 30, and then this one becomes VF sine 30. And then let me use blue. For the normal force, we are going to expect a force like this, okay, and another force in this direction like that. Okay, this angle here is 30. Therefore, this NF is NF cos 30. Then this one is NF sine 30. Okay, is that fine? So we have those components there. So need to sum them, apply the equations of equilibrium, and then we solve them. Right. So let's start with summation of forces in the y equal to 0. What do we have? We have NF sine 30 plus VF cos 30 and then minus 2400 is equal to 0. So let's make one subject to the formula. NF is going to be equal to 2400. 2400 divided by sine 30. Okay, and then minus VF cos 30 divided by sine 30. Right, so we have this. Therefore our NF, if we simplify it further, it becomes sine 30. This becomes 4800, and then cos 30, do we have this number is not too good, but we can still use it. 1.7321 VF. It's not bad. Alright, there we go. So with this, let's sum up the forces in the x direction. Let's see what we have. We have minus NF cos 30. Then we have plus VF sine 30. Then we have plus 1847.52 equal to 0. So we are going to replace this NF, which we've just found, this one here, we'll replace it here. Okay, so if we did so, then we'll have minus, we multiply by minus, what do we get? We'll get a minus 4800 cos 30, and plus 1.7321 cos 30 VF. Okay, right, we're multiplying by all of them, right? So this by that, we get that, and then this by that, we get this, right? Then plus VF sine 30 plus 1847.52 equal to 0. So let's find what VF is. You can find it. So minus 4800 cos 30 plus 1847.52. Alright, we have a negative number, great. Then divided by 1.7321 cos 30 plus sine 30. Okay, there we go. So what we have is VF is equal to 1154.68 pounds. Now, can I get back to this? So we have 2400. Okay, there we go, minus 4800 cos 30. Right, and then we have plus 1847.52. Okay, then we have 1.7321 cos 30 plus sine 30. 1154.68, right? Okay, so there we go. Let's find what NF is. NF therefore is equal to we can just use this equation here, this one here. So NF is going to be equal to 4800 minus 1.7321 times VF, which is just 1154.68. Alright, so this one becomes a 2000. Let me use black. This becomes a 2,800 pounds. Alright, so we found NF, we found MF. Let me just circle this. So this is our MF, and this is our VF, which is the shear, and then this is the normal force. Okay, this is the normal force. Right, so having found this, we'll now need to find the shear, the internal forces here. Okay, so we'll need to redraw this and then work on this quickly. So there we go. So we have this shape like this, and then we have this part, and then we have this part. This is what we have. Okay, so if this is 60, it means this one here is going to be equal to 30 degrees, right? So that is 30, and then this is given. This one is given as 1.5 feet. Right. What other extra information do we have? This is about it. Okay. We also have this angle here. This angle here is given. This is 30 and this is 90, right? So if that is the case, so we have this inside angle here. This inside angle is given as this is 90 plus 30, which is 120. So if that is the case, then we can find this. It's 150, 180 minus 150. So this becomes a 30, right? So if that is the case, then the problem even becomes much easier. Okay. So with this information, then it means we can find the side. Okay. So we have sine 30 divided by 1.5. Let me call this length. This length, we already know it. I mean, by this is B. This is BA. Okay. This point is C. So this is going to be equal to BA. I mean sine 32 just divided by BA. So BA is equal to 1.5 feet. So this one is equal to 1.5 feet. This is 1.5 feet. Okay, and so is this one there. Alright, so with this information, let's now take moments about H and the rest of the work. So say summation of moments about point H equal to 0, anti-clockwise being our reference. What do we have? We have 1847.52 times 3, anti-clockwise of course, and then we have clockwise 3695.04 cos 60 by 1.5. Alright, what else? That's all. And then we have the plus mh then equal to 0. Therefore our mh is going to be equal to, let's calculate it, 1847.52 by 3 minus 3695.04 cos 60 by 1.5. Okay, so we find that our mh is going to be equal to negative 71.28 pounds feet. Alright, 1847.52 by 3 minus 3695.04 cos 60 by 1.5, 2771.28. Right, great. So we found one part. Let's also sum up the forces in the y, summation of forces in the y direction equal to 0. What do we have? We have a plus 2400, and then we have minus nh, then we have minus 3695.04 sine 16, and is equal to 0. Therefore our nh is going to be equal to, and we have 2400 minus 3695.04 sine 16. Alright, so we have NH is going to be equal to 798,800. This is equal to 800 minus 800, right? So this one is giving us minus 800 pounds. All right. So NH will have to face the other side, right? Okay. Okay, so now let's find the summation of forces in the x direction. Summation of forces in the x direction like so. Okay. So what do we have? We have a minus 1847.52 plus 3695.04 cos 60, and then we have minus our VH is equal to 0. Therefore, our VH is going to be equal to minus 1847.52. This is a 0, right? 33695.04 cos 60. Right, so our VH is equal to 0 pounds. Alright, so we have VH equal to 0 pounds. G is the shear force. Then we have the normal force equal to minus 800 is supposed to NH equal to minus, so it is supposed to be in the opposite direction. And then we have the moment is equal to minus, also it is supposed to be in the clockwise direction. So this is about it, and I hope okay. This is the summary of the solution. We have the section at F in this part, okay, and then we have the section H, this part. Okay, so I hope the video was helpful, and if it was, give me a thumbs up, like my video, share my video, and continue subscribing. Bye bye, and see you in my next screencast.